Hi everyone, in this video I'm going to talk about the derivative of a function. First, let me provide the mathematical definition of a derivative, which is f prime of x is equal to the limit as h approaches 0 of the f of x plus h minus f of x divided by h. If f prime exists, we say that the function has a derivative or is differentiable. The derivative, or f prime of x, provides a precise mathematical way to determine the rate of the change of a function at any point. We know that understanding this concept is fundamental to calculus and has application in many fields, including physics, engineering, and economics. As we know, Newton and Leibniz developed calculus independently, and both of them made significant contribution to mathematics, physics, philosophy, and astronomy. The notation they used is different from each other. Newton introduced the dot and the prime notation to represent the derivatives. This notation is still used in some area of physics and engineering, especially in the context of time derivatives in mechanics. On the other hand, Leibniz introduced the differential notation, which is more algebraic and formal. In the Leibniz notation, the derivative of a function with respect to x is written as dy over dx, where dy and dx represent small changes in y and x respectively. We know that Leibniz notation is widely used in modern calculus because it is intuitive and flexible. It easily accommodates the operation of a differentiation and integration and works well in various branches of mathematics. And this differential notation clearly indicates the variable with respect to which differentiation is performed, making it easier to handle functions of multiple variables. So I mentioned different notations here just to give you a hint so you do not get confused if you see a different notation based on the context. Now let's calculate the derivative of some functions by using the math definition. The procedure that always we should follow for any function is composed of three steps. The first one is writing the expression for f of x and f of x plus h, and then expanding and simplifying the difference quotient. And the third one is finding f prime of x by evaluating the limit. So let's apply this series of steps to calculate the derivative of some functions. As our first example, let's find the derivative for this function by the mathematical definition, which is x squared. Our first step is writing the expression for f of x and f of x plus h. We know that the expression for f of x is x squared, and the expression for f of x plus h is equal x plus h squared. Our second step is expanding and simplifying the difference quotient. So we should expand and simplify the x plus h squared minus x squared divided by h. We know that the x plus h squared is x squared plus 2 times x times h plus h squared minus x squared divided by h. After simplification, we have 2 times x times h plus h squared divided by h. If we factor the h from the numerator, we have 2x plus h divided by h, and these two h cancel out each other, and the final expression is 2 times x plus h. Our third step is using the simplified quotient, which is 2x plus h, and find the derivative by evaluating the limit. We know that the f prime of x is equal to the limit as h approaches 0 of 2x plus h. And the answer for this limit is, by substituting the 0 here, we have 2x. So the derivative for the function of x squared is 2 times x. As another example, let's find the derivative for the function e to the power of x. We simply should calculate the difference quotient, which is f of x plus h minus f of x divided by h. The f of x plus h is e to the power of x plus h minus e to the power of x divided by h. By factoring out the e to the power of x, we have e to the power of h minus 1 divided by h. By taking the limit as h approaches 0, we have e to the power of x times e to the power of h minus 1 divided by h. We know that the limit for these parts is 1, so the limit as approaches 0, e to the power of x times 1, which is e to the power of x. So the derivative of the e to the power of x is equal to the e to the power of x.